Hi Jim, how you doing?
I'm good. How are you?
I'm great, and thanks for coming.
Oh, my pleasure.
Before we will start, would you mind to introduce yourself a little bit?
Sure. Yeah, my name is Jim Callahan. I'm a old software developer, I guess. I've been doing software development professionally since the early '90s in a variety of industries. I started off doing a lot of graphics related things, video games, visual effects for movies, that kind of stuff. And
That's
then
great.
I eventually got into doing visualization for machine learning and machine learning itself, and that
Hmm.
led me into financial industry. And I've been doing fintech related stuff in one way or another for probably the last 10, 12 years, something like that.
10, 12 years. And for a while, it's all in Clojure, right?
Yeah, I would say for the last 12, 13 years it's been in Clojure, but um, I think I learned my first functional language, which was Scheme, back in,
Uh-huh.
I want to say like early '90s. So
Early 90s.
and I've gone through pretty much all of the different mainstream functional languages like Haskell and Camel and ML and Scala and you name it. So I'm a kind of a language junkie. So whenever something new comes out, I go
That's
through it.
awesome.
And Clojure's been kind of my weapon of choice, you might say, for the last decade or so.
A decade or so. So if there was no Clojure, what would you use?
Oh boy, I might be forced to go back to something like a very trimmed down version of Scala or Haskell, maybe, or I'm not sure. I mean, the problem is that Clojure really filled a lot of gaps that was missing before. Uh,
Yeah.
I wanted a language which would run on an ecosystem that was broad. The problems with
Hmm.
Haskell and SML and stuff like that is they all have these very like closed runtimes, and if you want to like I don't know, parse an email header or something. It's like written by some guy 8 years ago who hasn't maintained it, and things like that. Whereas in the JVM community, you have this wealth of stuff that's been really
Yes.
written up. And I think having being able to write a functional language in a runtime that has multi-threading and which has a large user base, I think Scala was the only other one that really fit that bill for me before
Yeah.
Clojure, and Scala was just way more complicated than I really wanted to deal with, and Clojure became a much better tool of choice for that. And I've always liked
Yeah.
Lisp, and so I was happy to kind of go back to Lisp, which was now much more kind of pure functional oriented, rather than being
Yes.
more imperative like Common Lisp or Steam or
Yeah.
things like that.
I love to say that Clojure is the highest level, still practical programming language in the world. Uh, because potentially in Haskell, you can do crazy things through monoidal functors and applicatives and other things. But the ecosystem is not as big. Many things are missing. In Clojure, anything like you want to connect to any type of database, any type of queue server, any form of data format you need to parse or generate, the support is there. So you are not missing any ecosystem, and you can interact with almost like or everything that exists, which is great. Um, and what are you working on right now?
I suppose the reason why you're talking to me is a talk I gave last year's conj about something called Fire, which is this kind of functional, immutable, graph-based, reactive kind of system. I'm working on kind of the successor to that now. So it will eventually be an open source project, but I haven't not yet at the point where I'm ready to show it to the world. But it's going to be called Zest, and continuing along the thought pattern of where I started there, taking it to kind of the next level. So. Um, yeah, I've been doing that
So,
pretty much for the last 6 months or so.
yeah, for people who didn't see your presentation file on Conch, um, the the main thing is basically it is append only event sourcing log. with a graph attached to it, right? That is representing computations or transformations or potential reactions to data. And that's what you, at this moment, use at Splash Finance. So what were the good things about it? And at the same time, what were things that you would change and are the reason that you are building something new?
Right. Um, well, I mean, this is a little bit of a tricky subject to talk about, and if you see my talk, you'll have an understanding why. Because I can give it to you sort of in a thumbnail, and then maybe we can go deeper. Uh, so I think at the high level, you captured it okay. It is an event sourcing based system that has an event log. It's an event system.
Yeah.
Um, it uses a CQRS or command query responsibility segregation approach to things. So it has a central processing or evaluation engine that is separate from querying and other kinds of like data accessing patterns. That evaluation engine itself is graph based. So
Mhm.
we represent a business process as a directed graph in which all new facts that you learn from the world, like could be the user giving you something, or maybe you get a response from some service, from some partner service, like in our case, maybe getting a credit report or something like that. Um, those are like leaves on the tree, you could say, right?
Yes.
All the new information you learn is some leaf on the tree, and that triggers
Yes.
evaluation downstream in the graph. And the consequence of that is that you make a decision of some kind, right? So it could be some basis of some calculation, like maybe you figure out new rates to give a loan, like in our case, or maybe just even the ultimate decision: should you even give the loan or not? Should you approve or deny the loan?
Yeah.
What's interesting, and which I think is a little novel about Fire and Zest, coming out, is that this is really a cyclic process, right? You can imagine if you begin some process like this, you know nothing, and you learn a bit of information. Now you know a little bit more, but the question is, well, what do I need to know now? And one of the principal properties of this is that the system is able to figure out which leaf nodes will help you progress the computation.
Yeah.
So essentially, there's a back and forth, let's say, with the front end, where the front end says, well, what do you need? And the back end says, well, here's a list of leaf nodes that if you gave me, I could make progress. The front end decides what it wants to show to someone, collects some information, sends it to the back end, and then the back end sends a new list of now what I need to know. That list could either grow or shrink, depending on what the evaluation determines. And so this process kind of continues. You go from sort of this indeterminate state, like I don't know whether say to approve or deny the loan, and eventually you get to a point where you can say, yes, I can approve it or I can deny it. And that's sort of the conclusion of the application process. And so what you could say is that Fire is a way of running these kinds of business processes that I just described, right? And
Yes.
each of the nodes that are not the leaf nodes are pure functions. So
Mhm.
we have a couple different names for them, and there's some stuff we can get into about asynchronous processing. But the gist of it is that every step along the way is a pure function that knows exactly what its inputs are, the leaves upstream of the tree. It knows what data it produces. That's an event. And every node that gets evaluated produces an event that gets added to the log. So every time
Yeah.
a new fact is entered into the system, that causes an evaluation of pathway through the graph. That creates a set of events, which are called generation. And those generations
Yeah.
are atomically written to the log. And that's how it proceeds. So if you were to look at a particular process, like say a loan application, what you would see is a series of these generations. And you would know every single evaluation of every node in the graph, as well as every input fact that happened all throughout the history of that process.
Yeah. When you were designing this, did you envision it to be exactly like this, or did you go through multiple iterations to get there?
Kind of both. So I think what you could say is that this is not my first or even second attempt at building some sort of event sourced functional system.
Hmm.
This, I believe it is the fourth or fifth, depending on how
Hmm.
you want to count things, Now, each of those things had been in different industries with different objectives, and therefore some differences in architecture and constraints like that. But I would say that each of those experiences taught me something that I added to the next layer. So by the time I got to Fire, you could say I'd already sort of kicked the tires 4 or 5 times.
Yeah.
And so it wasn't really like a blank piece of paper approach. I had some good ideas about what has worked in the past, what hasn't worked, and some new
Yeah.
ideas that I would like to try and add to that. So it was a sort of an iterative thing onto a base of knowledge that I had built up and had high confidence in. I would say largely, and we also went through a very good design process. And I think this is something we could maybe talk about even independent of other stuff. But we spent about 4 or 5 months, I would say, with the top half dozen engineers at the company discussing this. Now we didn't do it like 10 hours a day every day, but it was a long discussion. We concluded with us writing like about a 30 or 40 page design spec that was very specific about what it should do and what it's almost like a reference manual in a way.
Yeah.
We wrote it, and what we implemented was extremely close to that. We thought about it very hard, and we made a lot of in-depth discussions and decisions before we got to the point of touching the keyboard and writing the code. And when we actually sat down to write the code, I think the base infrastructure of it we wrote in about 6 weeks. And we built a product for doing home HELOC loans, which are basically home equity loans. Like you borrow money, equity in your house. That process had 3 back-end engineers, 2 front-end engineers, a PM and an EM, and myself.
Yeah.
And I'm also acting as like the highest level engineer in the whole company. So I'm also overseeing other projects and stuff like that too. So I wasn't like that much time comparatively on the keyboard. We built that product from the start, including building all of the Fire infrastructure in 7 months.
Yeah.
Now, to give you a comparison of what that's like, even at the same company, their previous product, a personal loan product, took them 18 months and 65 engineers to build.
Oh, okay. That's a massive difference. In this architecture, there is this immutable event log that's up and only, and then you have this graph. And when you have this graph that represents computation, in a way, it's a program, it's an algorithm. And in this algorithm, you can call functions, you can change state, you can filter things, map things, etc.
Not all of it, but
like you represent different like things that you already have in the programming language, but on higher scale.
Yeah.
And each of those functions might represent a piece of business logic. And I can imagine everything, but in this architecture, and I have been involved in projects that use the same architecture, the only thing that seems cumbersome to me is when you need to loop back to the beginning, because it is usually done that you insert new event that will trigger the new flow, but then it's harder to debug that I have like this first half and then I go to beginning and run again, that you want to connect those 2 runs together, because in that system they are seen as independent events, right?
Yeah, I think a couple things to unpack there. The first is you can think of it as sort of a DSL or a higher level programming language, like built on top of Clojure, or that Clojure is like the expression language in this system.
Mm-hmm.
Right? So it's like if this was a spreadsheet, then like Clojure is the expressions you can write in the cell of the spreadsheet, right? But with some highly constrained limitations. The function that you can write for a node has to be pure. It cannot do any kind of I/O. It cannot talk to anything at all, right? It has to, and that gives us a degree of determinism and transparency to the system that you wouldn't have otherwise. In fact, I looked at it when we finished the HELOC project. I think there was about 4,000 lines of code, and there was not a single line of I/O in any of it. It was just a huge batch of pure functions, right?
Yeah.
So all of the I/O, the processing, the networking, all of those kinds of parts of the system are done outside of what the programmer is focused on, right? They're sort of like for free, right? They're just part of the
Yeah.
system. Now, in terms of what you're talking about, another important thing to say is that the granularity of these nodes in the tree, they are very specifically tied to what I would call a significant business event.
Hmm.
These are not simple things like just adding two integers together. They're typically things, they could be, but like they're typically things that have what any business person or operations person you would talk to would understand to be the meaning of something, like generating a rate or
Yeah.
computing your monthly debt or something along those lines, right? So they don't look like, they don't suffer from this sort of confusion of communication that you typically have if you have, like, I don't know, like some relational database with 1,000 tables in it, and like
Yeah.
tell some business person, here's the name of a column in this table, and they're like, I have no idea what you're talking about, right? So there's a sort of clarity of understanding of these processes that they're not massive trees. They're like trees with like 100 nodes or 120 nodes in it, not
Yeah.
thousands or tens of thousands.
Hmm.
So they're not a replacement for writing Clojure, right?
Yeah.
You're still doing most of your work in Clojure itself, like inside these functions that are in the nodes. The nodes are the scaffolding about how things relate to each other and how they have these data dependencies between each other, right? Now, your point about looping, and so I think another thing to kind of understand here is these nodes are not each individually distributed across some large system in which they're communicating over the network with each other, right? These nodes exist, the graph exists within a single service. And when you say, I call it an observation, which is a new fact, it would be one of these leaf nodes. That observation triggers this chain of evaluation, this generation. That generation is a synchronous atomic activity.
Yeah.
Okay. So there's not like this process as a bunch of things kind of like dynamically like looping around and communicating with each other in a way that is not easy to understand. Like it is very straightforward that I introduced this new fact. I said what my income was. That led to a new rate being generated. I can see that as a thing. Now,
Yes.
there are times where you need something that happens in the process to later trigger more computation, right? Which I think is what you're talking about. And that could even be something upstream of itself, which is sort of like what you're talking about, that loop, right? So the typical example of that kind of thing is something that has some sort of time expiry to it, right? Like maybe after 3 days, there's a law in Texas about making loans where you have to give them 3 days to cool down or something like that.
Yeah.
You can like back out of the loan, right?
Yeah.
So we have to have a process where you say, okay, we've closed the loan. Now in 3 days, we need to start another process. And
Yeah.
the way we can handle that is we can make what we call delayed observations, which are you kind of make the observation now, but the system doesn't deliver it until 3 days from now. And then it begins again.
Yeah.
So
Yes.
you can do things like that. You can also call out to other services, like give you an example, like getting a credit report. So
Yeah.
you might wonder about that kind of thing because that's clearly I/O, right? But the way it works is we have a kind of one of these interior nodes called effects. And effects, essentially, all they are is they create an event that says the intention to learn something, right? So the content of the event is just written like every other event into the event log. And then there's some other process, like say the TransUnion process, that's reading this event log. And when it sees these, I want a soft credit pull event, it goes and calls TransUnion, figures something out, and then it goes and makes a new leaf node observation based on
Yeah.
that. So there can be this kind of loop in that way where some evaluation of a process leads to an effect, some other process picks up that effect, and then later makes an observation that starts the computational process again. I think that's another kind of loop, like you're saying, but they're not written like a while loop in a programming language, right?
So I think that those loops occur in situations where you don't know in the beginning that during that you will need a loop, which of course is a situation where you depend on side effects. Then you have pure functions. In pure functions, you can take parameters, a name of the function, replace it with result, and nothing changes. So everything is known, and you can actually, even in the beginning, of the whole flow, you can reason about if you will need to restart or not.
Yes.
While then you have side effects, like for example, some ETL or calling API.
Right.
And if the API is not working and you need to retry, a good way is to say, okay, let's increment try counter and restart the whole flow. And start in the beginning, but try attempt is not one, but two.
Yeah,
And
the way you should think about this is that so the TransUnion thing I was talking about, we like to call these observer services. So think of it as there's a central service that's sort of the evaluation engine, and then there can be any number of these kind of microservices which are responsible for handling the side effects with external systems, right? So this observer service that's talking to TransUnion, it's the thing that's responsible for retries, for credentials, for maintaining idempotency, for those kinds of things, right? It doesn't do any business logic at all. It doesn't make any decisions about things, right? But it is the maintainer of that sort of side affecting relationship. And what you could say is that the evaluation engine doesn't in any way depend on any guarantees of a response from that. So in other words, it makes an effect event that says, I would like a credit report, but it's not waiting around for a credit report, right?
Yeah.
It reacts to credit reports happening. So it's the evaluation engine is always pure functional. It never has anything that looks like a side effect in its code, but there are external systems that act in side affecting ways and can produce new information that comes into this pure functional system. So in that way, we've like very clearly kind of separated concerns of these two different kind of processes. So like, for instance, I don't know if I ask TransUnion 5 minutes from now for your credit report, if it will give me the same credit report. You could have just done something like gotten a new loan that got this credit report. So there's no way to guarantee that the call to TransUnion will be pure functional anyway. Right? Like it's inherently can't be. Right?
Yes.
But the fact that you told me your credit report can be pure functional, that credit report did happen at a moment in time, and everything that was computed beyond that is based on that credit report. And if a new credit report happens, that's a new fact, and there'll be a new set of computations based on that. So we can very clearly separate that pure functional aspect of the evaluation engine from any of the side effects things. Right? You still need all the kind of observability and reporting and alerting and other stuff to see if TransUnion is down and all that kind of things. But the evaluation engine itself can always be pretty simple about how it works and very easy to reason about, which I think keeps you out of getting into like complicated loops about not knowing what's happening or what should happen or things like that.
Yeah, there is like two aspects that I realize are like when you have leaps where you end up, these could potentially cause a side effect that will end up adding new event to the stream. Another thing might be actually like even those branches that are purely functional might not have any side effects, but they might accumulate. I will need this data. So the last step will actually call, okay, and by the way, I need this data. So your intermittent computation is completely purely functional. But the last leaf will actually cause all of those side effects. And as they are happening, you might wait for all of them to finish, or as they are happening one after other, you might be inserting them to event log and they are being processed.
Yeah, I think a really important point about how to think about this and how to reason about it and why it's easy to program this way is that the graph makes no assumptions about ordering. Like those leaves could happen at any time or never. Right? Like there's nothing that you would have to consider in terms of how you write this that would make any sort of assumptions about what events might happen in the future or what order they might happen. And so you're able to think about like the one node you're writing the code for, maybe a couple nodes that are related to each other in a very sort of insulated, independent sort of way, and have confidence when you combine them with these other nodes, it will just work.
Yes.
It allows you to create things that are fairly complicated without yourself having to onboard all of that complexity. Because I think one of the biggest impediments to productivity as a software developer is, let's just say a product person comes to you and say, we're thinking about doing this. Like how hard do you think that is, right? for most people, what that means is going and digging through a complicated set of relationships across multiple services and trying to figure out like what the blast radius is of that perceived change, right?
Yeah.
This really doesn't exist in this approach, because anything that you would add, like a new node that you would create in some new tree, can by definition not affect anything that already exists. So there's no way to break what already exists. All you're really evaluating is how hard it is to add the functionality you're talking about in combination with
Yeah.
what already exists, which you can use as building blocks, as off-the-shelf things to combine with it.
Yeah.
It just becomes like incredibly straightforward to understand what it might take to accomplish. I think this is why that productivity gain I was telling you about earlier is so profound.
Yeah.
Is because for the same reasons that writing a pure function is better than writing a bunch of global data that stomp each other. You know,
Yeah.
like
Yeah.
it reduces
So
the complexity of the problem to a place.
it's not just pure functions. You basically need the structures of inputs to be in the same shape. Or like you were working in Haskell. So basically in Haskell terminology, if you were building the same thing, basically you would have homomorphisms that need to be associative or commutative. And then basically they match together inputs and outputs. So you can reorder them, you can fuse them, split them, and they will be all compatible. A good thing is about Clojure is you have no ceremony around this. You don't have to say it must be a semi-ring in monode-based aggregation. You just say it has the same shape.
Yeah.
So this gets a vector and it returns a vector, for example.
I think that's a good thing to talk about, which is this system has a kind of duck typing, you might say. So,
yeah.
Let's take one of those interior branch nodes. Okay.
Yeah.
So it has a couple inputs and it has like an event that it produces as its result.
Yeah.
Okay. So we use Mali to describe the schema of the event it will produce.
Yeah.
We also describe the schema of what the inputs must match, right? But that schema is a minimal schema. It's not a closed schema, right? So for instance, I could write some node in my graph that, let's say, like picks the interest rate based on your FICO score and your income, right? Now the credit report might have a FICO score in it, but it might also have like 120 other things. I can plug a credit report into that node because it has a FICO score. I could also plug anything else in there that has a FICO score. I could just like have a node that's just an observation from the world. Like I just type in what I think your FICO score is and plug that in there. So
yeah,
it is very strict in enforcing that those connections have to match each other in a schema way. But it's also loose in the sense, that's why I'm saying kind of duck typing, because it doesn't say that they have to be a specific thing. It just they have to support certain constraints.
Yeah. Like instead of saying it must have these 40 attributes, it says it must have those 5 attributes, and the result will, and there might be any other attributes, and the result will have those other, let's say, 5 attributes.
Yeah.
And as long as you use it as a validation runtime, and if you run the code, it's actually giving similar guarantees to having static typing. Like this is one of the things I found that having system like Mali is very expressive, Clojure spec, even prismatic schema. When you actually run your application, very often it finds bugs in your data shape super quickly. And the fact that you don't have a compiler in place that would tell you is not such a big issue. Because when you run your application and you have those validations in place, Mali or spec will tell you about those issues very quickly. And I would say that in some way it's more productive, because in REPL you can experiment with the shape of data.
I think we take advantage of all of those things, really. We're doing a form of static analysis in terms of how we compare the schemas of these things. So when you construct a graph, when you say I want to connect A to B, it's doing an analysis right then about whether A should be able to be connected to B. Right?
Yeah.
Now, on top of that, we do unit testing at the node level. So you could say, okay, I'm going to write a function for a node. It knows what the spec of the node is, so it knows how to use generators to generate input for that and to see
Yeah.
what your function produces. And we can do a bunch of generative testing on that one function to see
Hmm.
whether you've written your function badly, like you're depending on something you didn't really provide, or you're providing information you shouldn't provide. By the way, the value schema, the output schema is closed. So if you try to produce data that is not expecting, that's not okay. uh,
Yeah.
and then like on top of that, we can run like full graph tests. So we can run, okay, we have a series of 10,000 loan applications with like each one has like 300 or 400 events that come in, and then like we know everything that should happen, and we'll see if all of those things work and perform as so even before we deploy a runtime thing and see a problem there. But in runtime, we're also checking that every single event produced is checked against the schema before it's written to the event log. So we know that it's impossible that there's anything in the event log that hasn't passed the schema. And if it doesn't
Yeah.
pass, we're going to throw an exception, and we're going to import the whole computation back to the leaf node, and we're not going to write that
Hmm.
information to the event log. So it's impossible, even if you have a failure in the middle of your graph, to get in some sort of weird intermediary state where you've half computed it and now you can't
Yeah.
continue or something like that, right? So it's really
Yeah.
like it's like belt and 2 pairs of suspenders or 3 pairs of suspenders in terms of this kind of checking. Like it's not as strong maybe as Haskell is in that regard, but
Yeah.
I think it's so much more flexible than Haskell is, that you're able to write with, because you can write any function you want as a schema
Yeah.
evaluator or validator.
Yes.
You have a great deal of flexibility how to write these things, and I think in practice it's very rare to see a runtime
Yeah.
exception
Yeah. Those
failing.
asserts or like schema checking in runtime code where you can create any function that validates shape of parameters or return value. It's super powerful. Of course, in Haskell you can type many things, but it's focused on types. Then you have languages with dependent types, like Iterative. I use Iterative. It's very limited. There are many things that you cannot type. Nowhere as easy as you just write a validator in Clojure.
Yeah.
So, and the point is, if you run your code, and especially if you have a battery of 10,000 tests that cover use cases you run into, it will give you a high level of safety. I have seen some study that basically said that the quality or number of bugs is not related to whether the language is dynamically typed or statically typed, but if it's more high-level language or low-level language. So basically, Clojure being dynamic language, still you will have fewer errors per line of code than C, for example, which is lower level language.
There's so many ways to shoot yourself in the foot with C. It's
Yeah, yeah.
yeah, it makes sense.
So if Clojure is very high level language, you can expand. Also, it's expressive. You read the code and you understand what's happening in the code.
Yeah,
And and by being a functional language, it's not only Clojure thing, but for all functional languages, compared to, let's say, Ruby, there is no hidden state somewhere. So you don't have a function that mixes in some global variable that suddenly changes behavior of your application. You could do it in Clojure, but people don't because they perceive it as a bad practice. Yeah.
although I would have thought that. And to be honest with you, one of the things that's been a little bit disturbing to me working professionally as a Clojure developer is it is not uncommon for me to come into a company and look at their code base and see it filled with atoms and practices that I wouldn't believe that anyone who'd seen value of values talk from Rich Hickey would possibly
Yeah.
write. But I think it is not universal that just because you're writing a program in Clojure that you fully understand the concepts and are adhering to the principles. You can always write bad software in any language.
Yeah.
It doesn't force you to become a better programmer. It's a tool that if you are a better programmer, you can take advantage of. And I think in a lot of ways, one of the things I've come to understand as I've gotten older and had more experience under my belt is that I think the difference between someone who has 30 years of experience and someone who has 5 years of experience is how many times they've shot themselves in the foot and how many times
Yeah,
they've done things that were good intentioned but ended up causing them lots of pain and difficulty, and they know how to avoid
yeah,
those things, and they know what not to touch. They have a kind of a spidey sense of like, I shouldn't be doing those kinds of things.
yeah,
And you're kind of young when you're younger and a little bit more foolish. You're more adventurous. You're willing to just go off and do a lot of things which I now would never do because I feel like
yeah,
it's way too dangerous and gonna bite me in the end. Um, and I think in some ways, some of the stuff I've done with like Fire is to try to codify some of those principles in a framework that allows you that sort of enforces some of those constraints, right? That takes a sort of in a lot of ways sort of takes away from you some of your
yeah.
flexibility and forces you to think in a more constrained, more focused way about the problem you're solving, rather than kind of having this smorgasbord of options to do that you can get yourself in trouble with.
So there is, it's true. I agree 100%. But still, like even a Clojure world is not immune to things that have been a fashion in a way and have been overused a little bit, like microservices. I definitely think that microservices are a little bit overused in the Clojure world. So still we are not immune, even when I think that
Yeah.
Clojure definitely attracts developers who shoot themselves to the feet more times than average.
Well, I think
And
there's a kind of a self-selection, you might say. Like one of the things I like to sort of tell HR people about hiring Clojure developers is you're more likely when you find someone who has Clojure experience, they're more likely to fit certain profiles because they have to naturally have been curious. They're the type of person
yeah,
who's willing to try things out of the norm and make evaluations for themselves. But there's no guarantee that that the conclusions they come to are the right conclusions. But it certainly helps to sort of self-select. I think it
yeah,
also sort of self-selects for experience too. Like I typically the people I see doing Clojure, this is not the first language they learn. This is like
yes,
the 12th
yes,
language they've learned, or something
yeah.
like that, right?
I
They're coming to it with a wealth of experience and other things that led them.
In my life, I have been in Clojure ecosystem for some 13, 14 years, and I have done hundreds of interviews with candidates, obviously. In my life, I have met only 3 people who worked only with Clojure professionally in their life. It's like less than 1%. And it shows the quality of candidates is much higher. Like, if I would say, Clojure is probably the highest signal to noise ratio in candidates, while JavaScript has the worst noise to signal ratio. Like I need to interview up to 10 times more candidates for JavaScript than Clojure to hire the same quality.
Yeah. Well, I think there's something sort of disturbing, and maybe this is about people in general, it's not just about programmers, but like I'm a little dismayed by how susceptible we are to fads and trends and styles and things like that, to cargo cult kind of behavior,
Yeah,
right? Like I've yet to hear anyone explain to me why Python is logically the best language for doing machine learning. Like it makes no sense to me. Like it's
so it isn't. It's like all the machine learning you do in Python is being offloaded to C++ or highly optimized C++ code,
or to
and
Fortran,
Python, yeah, Python or Fortran. Python is a DSL. That's calling it,
right? But
and
if you were to
and it,
say, like, what's a great like dynamic way to like call low level numerical computing?
yeah, but
Is Python
it's a
really the choice of syntax that you would use for doing that?
yeah, but it's a coincidence, right? Back in the day, Google was using C++ and Python for high-level code that did not have to be super fast. They invested money to make it do machine learning, uh, and at the same time in academia, unfortunately, some universities stopped teaching Scheme and started teaching Python and so on. But
Which is
uh,
absurd, Right, because
I,
the structure and interpretation of computer programming from MIT is
yeah,
one of the best textbooks on programming ever written, and
and but and it created reinforcing loops. So then you had those like students who were finishing universities who had experience with Python, and there were companies investing to, let's say, machine learning, and they were using Python. So it created, okay, we have people and we have libraries, so it makes an ecosystem. So here,
yeah,
there it is. If back in the day, if like those decades ago, Google did the same thing with Java or JVM, now all the machine learning would probably run on JVM.
yeah, and the same can be said for why we've ended up writing most of the world's software in JavaScript. It's kind of a weird coincidence that turned into some sort of fad that then got its own momentum, and it's not based on merit, right? No one in their right mind would say that JavaScript is a well-designed language. I mean,
Yeah.
it's awful. The
Uh,
fact that the world works on it is kind of amazing in a way,
yeah.
And they've made attempts to
I
try to make it better, but like it's really terrible. It's like it looks like the kind of thing that like some student may have written as their like introductory to programming, compiler programming course over the summer,
so many many years ago in 90s, I wrote a couple of VB scripts, and it was even worse than JavaScript.
Well,
Uh,
not worse, but like like
yes.
it's it's not what you would expect, right?
Yes.
You wouldn't have expected
Yes.
that to take over the whole world, right? And the only reason I bring this up is I think there are people who came to Clojure for similar fad reasons,
Yeah.
who maybe don't actually understand all that deeply, as clearly as Rich has said some of these ideas. I think maybe they've gone over the heads, or they've just missed the target from some people, and because I've seen multiple companies now who have written very large Clojure bases in which all of their services are written in a CRUD style, and it's a total disaster area in which
Yeah.
database access code and business logic are intermixed with each other in the same functions,
Yeah.
in which all of the principles that you would think about trying to write software in a modular, efficient way are just thrown out the window, and it looks terrible. I mean, I saw a namespace one time that I'm not joking had like 50 or 60 exclamation points in it, like
Hmm.
swap bangs, reset bangs, stuff like
Yeah.
that, right? I cannot imagine the application that requires that. I can imagine
Yeah.
no circumstance I can imagine where that is the best way to solve the problem, right?
So there was probably missing team lead who would coach people to write Clojure in the right style, I suppose. Um, because even we were speaking about that before, even when you hire somebody who was working in Common Lisp or other Lisps, it's no guarantee that those
Sure.
people will be writing highly functional style,
Yeah.
because Lisp languages usually were mutating data, using global variables, and so on. I have seen it in Emacs Lisp. I have seen it in
Sure.
GIMP Lisp.
Sure.
I suppose in Common Lisp it was common too. And Clojure enabled, made it possible to really write much more pure functional code outside of academia and Haskell world and so on. There was this other option, Erlang, but yeah, when I speak about even like hiring Lisp developers wasn't a guarantee that the code will be very functional.
Yes. Sure. In some ways, maybe it's better to hire a Haskell programmer because they're used to being pure functional all the time.
Yes, yes. A question is if Haskell developer is willing to convert to Clojure.
Give up their category theory.
Because you when you have it like category theory, it's terrible to put it like this, but you don't need any knowledge of category theory in Clojure, like not at all. Like you don't need to do Kleisler arrows. You don't need to know that applicatives are highly parallelizable. You don't need to know what is tropical severing and so on. Like
Yeah.
because all this ceremony goes away in Clojure.
And don't get me wrong, I love the sort of overlap of the Venn diagrams of mathematics and programming, right?
Yeah,
I think that
yeah,
a lot of ways why functional programming appeals to people,
yeah.
it seems a lot more like writing math than it does seem like
But
writing a laundry list. But like they're
yeah,
different things.
but the point is basically once you like have invested those like hundreds of hours, so you can think in those, when you can think in category theory, it stops being a problem. I have a friend who knows Clojure and Haskell just as much.
Mhm.
Uh, and he says that he is productive in both languages the same. It's just like in Clojure, the power is homogeneity and super powerful higher functions, and in Haskell it's category theory. You achieve the same things. But Clojure is, I will put it, it will sound terribly, but it's a language for plebs. There is no ceremony around it.
Yeah.
You take data, you transform
I
them.
think that's a badge of honor, right?
Yeah,
Like, I think
but in
Clojure is a language for people who like getting shit done,
yes,
right?
yes,
And I am a person who likes getting shit done. Like
yeah,
but believe me, I'm as interested in abstraction and nifty ideas as anybody. But like at the end of the day, I want to accomplish things,
yeah,
and
yes,
that's
yes.
what gives me a sense of satisfaction at the end of the day. Is that I feel like the world has been enriched and is now has more capacity and more interesting behavior
Yes.
than it had before I started the day, and I feel like I get that out of Clojure probably more than anything at this point.
Yeah.
Now, that said, if something better came along, I would switch to it in a heartbeat.
Yes.
I have no loyalty to Clojure as something wedded to for my identity or something like that. Like
Yeah.
it just happens to be the thing that I've bumped into that fulfills that best at the moment, right?
On my side, I am somewhat invested in Clojure. I want explicitly Clojure to succeed. I have many friends in the community.
Yes.
But at the same time, yes, my interest is to build applications. My interest is not to write scientific papers somewhere or write code to have a PhD, but is to make app that will help somebody to do something. And Clojure makes it super easy, and still like all of those concepts that exist in Haskell, it's dynamic language, so some of those things disappear. And you have no static typing that like, you have none of those advantages, but it's not a disadvantage, at least for me. But you get all the value. Like everything Haskell does, Clojure can do too, except that it's a dynamic language.
I feel like a lot of people, and I was in that camp too myself before. I would say that like my history of functional languages was mostly through strongly typed languages before Clojure.
Yeah.
I have to go all the way back to Scheme before that wasn't true, you know?
Yeah.
And my misgivings or my fears about Clojure before I really used it, I think are common to most people who come from this community, which is you're like, okay, that looks good as a toy thing, but what's going to happen when I write something complicated and I get some totally runtime bug and I can't figure it out, and it's a big sink of time. I think the verdict to me, having written Clojure for more than 12, 13 years, something like that, is that just doesn't happen if you know what you're doing.
It doesn't happen.
And
it doesn't happen. Yeah.
I think the biggest reason is the REPL. I think there are other languages which have REPLs, but I have not really interacted with another language that programmers who do it professionally use the REPL as much. The style of writing Scala code or Haskell code is you write a ton of code and then you see if you can get it to compile. And then you spend some time trying to get it to compile. And then hopefully once it compiles, it probably works. Right?
Yeah.
The experience with Clojure is you write a little bit of code, you see if it works.
Yeah. Yes.
And once you're really confident it works, you move on to the next thing. And then as you build those pieces together, it just works. And occasionally something doesn't work and you figure it out. But like, you just don't really get yourself into the kind of problems that people suspect that you might get yourself into who haven't done it. And so I would say to those out here listening to this who are interested in Clojure but haven't tried it yet, just go write some. I think you will find
Yeah.
just by writing it, you will eliminate a lot of what you think might be your misgivings for it. You know.
Yeah. Before I started working with Clojure, I was a massive fan of TDD. And in TDD, you work in super short iterations, test code, refactor, test code, refactor. But REPL made this loop even faster. And actually, when I started with Clojure, I was still like 100% believer of TDD. And I said, okay, with REPL, I will just prototype a function, but I will properly implement it with tests. And many times, by prototyping with REPL, I ended up implementing the whole function, and I had no test. I felt guilty because there was no test, and I was adding afterwards. I saw that as a sin, but over time you get used to how productive REPL is. Actually, TDD works the best when you explicitly know what you want to achieve, when you know what code you want to write. While REPL is great at this too, but it's also great when you just explore. And you don't exactly know how the function should look like, what parameters should be there, how the return value should look like. So REPL-oriented programming is more universal. The cycle is faster. I would say like it's better than TDD.
Yeah.
But if you told this to me 15 years ago, I would disagree heavily.
I think
But it is more productive.
I would say about Clojure, which every language sort of promises, and they almost none of them ever deliver this, is I've never before experienced a language when you go look at the source code of the core library that it's understandable and you learn something.
Yeah.
Right? Just go look at go take a random Java collections library class and go look at the source code to it and look and see what it's doing. And I guarantee you what you'll see is a bunch of weird nonsense that you're not sure what the hell's happening.
So yeah, in this case, like it will be either implementation of ton of interfaces or some form of monkey patching.
Something really, really weird and ugly, which just happens to be efficient or something like that. And
yeah,
I remember having an experience. I was trying to tell my wife about something about Clojure, and I was trying to explain how to implement some core functions, right? Like reduce and things like that. And I went and looked at the code of reduce, and I'm like, oh, that's an even better way. You know, it's like I've not really had that experience that when you look at the low-level implementation of the language's core libraries, that what you do is you learn how to be a better Clojure programmer by reading them.
Yeah.
Rather than it being an obscure nonsense that you can't really understand, you know.
Yes, yes. Let me check the implementation of reduce. Okay. Call reduce. Yeah. Anyway, like for reduce, normally, like one of those things in Clojure that is unexpected is that when you look into the source code, quite often the implementation is done actually in Java, not in Clojure for performance reasons. Reduce is that classic automorphism that you would be implementing through recursion in any other language, but Clojure would quite often have implementation that is not like purely functional, but might be implemented in Java in high performance way. This is one of the reasons why Clojure is so fast. But yes, big part of Clojure is implemented in very elegant Clojure. Also, one thing I like is Clojure is basically it's extending itself. So in some parts of Clojure, you don't have all the Clojure, right? So it's like from building blocks. Similarly, like you can implement the whole list from 8 core functions, if I remember correctly. So in the beginning, you say, okay, I have these 8 functions, and everything I want to add is using those so I have 8 functions. I will add 10 more. Now my language has 18 functions. Hooray! I can add more abstractions. Yeah. So, but I must admit that for people who want to read Clojure code, Clojure is not like this. There will be thousands and thousands of lines of Java code to make Clojure run fast.
I think it's fascinating.
It
I was giving a talk internally to some people about trying to encourage them to adopt Clojure, and I did some statistics, and I went and looked. So Clojure, I think, has like 10 or 12 core data structures and like about roughly 500 functions in its core library. But I think
Mhm.
people who write Clojure realize that you don't use 500 functions in your normal program. You might use like 25 or 30.
Yeah,
Occasionally you use one of the other weird ones, but like for the most part, you stick to a very smaller set of things, right?
that's true.
Java has 35,000 methods in its core library.
Oh yeah. So so that so this is partially caused by also encapsulation, because when you have a class and some functionality, and you have exactly the same functionality in other class, but because those classes are isolated islands, you cannot just say, okay, I also use it elsewhere. While in Clojure, when you have four basic data structures, one of them list, which is not used all that much. So let's say three main data structures. Even set is used quite rarely. Uh, all of those functions will work on those data structures.
Yeah. I find that for that reason,
And
it's a very easy language to get into, and it's very comprehensible. And even if you write, even if you look at the code written by someone who's written Clojure for 10 years, you show that to someone who's written Clojure for 2 weeks, they will still know what it's doing.
yeah,
Now they might be like, "Oh, what is Jux? I haven't heard of that before," or
yeah,
or something like that. But like,
yeah,
they'll be able to look it up and they'll be able to figure out what's going on. It's not. If you compare that to code written by an expert Scala or Haskell developer, I think you might
yeah,
very quickly get into a place where you have no idea what's going on.
yes, yes, absolutely. Uh, and we speak about, like, even in Haskell. So either the language is so deep that you can express things exactly as you want, which is definitely possible in Haskell. Like, you can express the same thing in many different ways. Or in languages like TypeScript or C Sharp, actually, they try to add syntax to shape one character here and two characters there, and then it might look like DSL. It might look nice, but actually underneath all that are many layers that could be simplified. Once I saw a beautiful article on a link in .NET. And it was all like they started with extension methods and they ended up with link, and all layers in between were valid C sharp. And it was great, but when I was reading it, I was like, it is awesome that it's not just new syntax they created, like they made multiple layers, so you actually can make it very extendable. But I don't want to learn all of this syntax.
Yeah, that's a massive cognitive load on the people,
Yeah,
and I think that's sort of, if there's some overarching sort of goal I have in general with programming, is to be able to focus more of my energy on the things that have significance.
yeah,
Like,
yes,
there's the whole like thing about like incidental complexity versus or everyone like essential complexity, right?
yeah,
To me, the ultimate like programming paradigm is one in which almost all of the code I write is essential complexity.
yeah,
And I think that's not just choosing Clojure as a language, but just choosing the way that you use Clojure and how you write systems and things like that. I think is all about trying to focus on what's most important and not introducing lots of trivial details that are not actually adding to your ability to accomplish the thing you're trying to accomplish.
yes,
And like just sort of like boiling it down to its most essential thing. And when you do, things look fairly straightforward. Like they're usually fairly comprehensible. Like they don't like take tons of energy to figure out what they're doing because it's not masked by all this garbage around them that hides
Yeah,
what the actual essence of it is, right? Um, I think a good test is like, look at like a page of code and ask yourself
yeah,
what percentage of the code on this page is doing the business logic.
yes, yes.
Like
So sometimes this was one thing I was always. I have no good answer for this, but should I create function that belongs to my domain, even when there is existing solution, existing function in Clojure, or should I use the underlying? So, for example, you want to sort something by two attributes, let's say lateness and cost, or name and cost. So the code is sort by juxt lateness cost, like as keywords. This juxt actually it is not business domain. So basically, you have to know what the function is doing. And the question is, should I wrap juxt lateness cost into by lateness and cost criteria, for example? So sometimes those high order functions in Clojure might be so expressive that you reduce it either even behind the business logic. And then there is a question even like, should you add helper function just to make the code more descriptive? Because like what you speak about is incidental, accidental complexity, right?
Like I think like every developer has a different level of comfort with that, right?
Yeah.
I think that there are probably extreme things on other ends of that spectrum, which everyone would agree are true, and then somewhere in the middle, we're going to start disagreeing with each other, right? Like I think in the case that you gave, I would probably not make a separate function just because it's so easy to look at and understand. But once that little juxt thing starts becoming like 5 lines of code or something in an anonymous function, then maybe.
Yeah.
Like it's also if it's maybe takes a little more cognitive effort to sort of understand what's going on in there, whereas a simple name might make it easy to understand what it's trying to accomplish without having to know that mechanism. Maybe it would be good to do it then. But I think that it's really hard to make any pronouncements, and a lot of people love doing this thing about exactly like how many lines of code should be in a function or something like that. Because I don't know, I worked with a guy back in the movie industry who wrote in a style, this is all in C++, but he wrote in such a style that he would never use more than like a letter or two for a variable name, ever.
Oh.
And he would write a function that's like, I'm not joking, like 5 or 6 pages long like this, with like super nested stuff going on. I would look at his code and go, oh my God, I have no idea what this is doing, right? This is like nightmarish for me to try to understand. Can you please just try to be a little bit more descriptive or something, or break out a function or something like that, right? Except his code was extremely reliable, extremely high performance, and he was doing something that no one had done in a movie before.
Yeah.
Okay, program however you want. I think that he would have looked at my code and said, oh my God, why do you have all these functions? Why is everything spread across multiple pages?
Yes.
I have to look stuff up.
Yes.
Like why are you using such long names? It's sort of like a matter of style. Like if you get to certain extremes, you might say like no one could reasonably say that's a good idea, except that he was actually really good at doing that. And he was the only guy writing that piece of software. And this is the way that he was most efficient at doing it. Therefore, it's okay.
I think there is certain like it is attractive to be able to express something as one-liner. Like you feel clever. I know I am guilty of that. Like doing those like combinations of map and map get to generate, I don't know, shorted path candidate expansion, for example.
Yeah, showing off how good you are, basically.
But then nobody can read it.
Right.
and actually like adding a function name, or what I like, and I would not say this is idiomatic Clojure, is actually using let and creating like helper variable, helper values with names
Yeah.
and using them, even when I could pass them,
Yeah. Yeah.
yes,
Yeah.
just to make core code more readable.
Sure.
Yeah, yeah, and 3 years ago we did April Fool's joke. So it was, I called it Unicorn Rainbow. It was basically that you could use all of those emojis in Clojure code directly in the code. Like you could make terribly colorful code if you wanted. And also I implemented it as a bunch of functions, but then after I was finished to make my April Fool's joke finished, I combined everything into one massive, completely unreadable macro, which led to the point that I proved that I can do this. It was one post walk that could like walk through your code and delete those UTF emojis in your code, and it is possible. But this was the point. But if I wanted to do any changes, I would actually start like 2 commits back before I did all this. And I would go to those smaller individual functions. Then I would do changes, and then I would like compile it back to one terrible macro, for the sake of fun. And I think sometimes those one-liners are more a proof that it is possible, but it's not like the most maintainable thing.
Yeah. Well, I think working with others is a different. Programming as a team sport is different than programming as an individual sport.
Yes.
Right.
Yes.
And
100%.
you have to sacrifice some of your own idiosyncrasies and preferences in order to have the good of the team in mind.
Yes.
And, I find that I write in a different style when I write projects for home that I know for sure I'm not ever going to share with anybody. Than I write much less tests.
Yeah.
I write some tests, but I don't write tests to the degree, like I almost write tests, I think, in a professional context as a sort of protection against the noob who comes along and doesn't know what it does and might try something.
Yes.
Right. As much as I'm writing it for my own self, it's like they have sort of
Yes.
like multiple goals there, whereas when I write my own code, I might be a little more adventurous in terms of doing without
yes.
that,
So that's the thing that those hyper expressive programming languages, you can express everything exactly how you want. And there was this an article, a curse of Lisp developers, something like that. There is no ecosystem in Lisp, because everybody wants his way to express things. And the good thing about Clojure is that we don't have this. We actually have just like 3 libraries for data validation that are really used.
Okay, but how many libraries do we have for writing a HTTP server?
Oh, yes, there is more of them. But, and for component, there is more. For routing, there is also one, but still,
I think you're kind of right. I think
routing rated is now like used by everybody. I liked BIDI, but like everybody is using rated now. For database, it's now like for SQL, HuckSQL and HoneySQL, everybody is using first or second. As a connection is JDBC Next, everybody is using that, for example.
I think what you're saying is more true now than it was like 5 years ago. I feel like certain players have started to win in some of these spaces, and like the consensus is that like those are the best approaches. But like if you look at a piece of Clojure code written like 7 or 8 years ago, it's probably using something like Composure or something like that.
Yeah.
So, which almost no one would do now, I think. Maybe I'm wrong.
Yeah.
Yeah, I mean, it's interesting. I mean, I like that there's at least 2 or 3 competitors in every area.
Yeah.
And
yes.
And in some areas it's not really yet decided who's won, but like, uh,
So when it's just two or three, it's fine.
yeah,
Uh,
if it's seven
the
or
the terrible
eight, Java,
terrible thing would be if every developer wanted to create everything himself. But when you have like, I still love Leiningen, I still love prismatic schema.
I'm sorry to
So
say, sorry about that.
uh,
I don't.
no, it's fine. It's fine. So I am not using prismatic schema on new things. I use Mali, but I still will use Leiningen, and and it's fine. The problem is if I build my own dependency management system, then I build my own like data shape checking library and so on. And I wonder like, why is Clojure different than Lisp, which has this culture of like everybody is creating his own thing. Yeah.
Um, I think the Clojure community has a relatively small number of people who are very productive.
Hmm.
You know, like Michael Borkand is how many things I've
Yes.
written.
Yes.
You know, it's unbelievable.
Yeah.
And
Yeah.
and
Sean Corfield,
yeah,
etc. Yeah.
yeah, and those people are sort of have, I think, sort of like, or pathbreakers, are sort of paved the way for ways of thinking of things, and they're a little
Yeah.
bit in their own ecosystem sometimes. It's like, um, but I think that it's a smaller community in a way. I think it being a
Yeah.
smaller community helps in a sense. I think it's you're a little bit more in touch with like what's possible and what
Hmm.
people are thinking is might be a good thing. Like it's like if something gets mentioned within a context of my circle of like people, it's usually something worth checking out. You know,
Yeah.
like for instance, I'll give you an example. I've heard of Polylith for God knows how many years, but just haven't actually explored it. And then finally, someone in my circle was like, "No, I took a hard look at it, and I think we should really use it." And I'm like, "Okay, I'll take a hard look at it." And now I'm using it, and now I'm loving it. But clearly, and forgive me if I don't know the name of the guys who came up with this, but there's some good thought in it was put into it.
Yeah.
I'm not saying it's perfect or it solves all problems exactly the way I would like it to, but like it's certainly there's usually an opportunity to find something where you're like, oh, the person who made this really put some love and craft into it. Like this
Yes.
was not just something like thrown out there to be the 18th version of the same thing.
Yeah.
Like they had some unique idea that led them to want to make this thing.
Another reason why I think that we don't have like crumbling ecosystem is actually that in Clojure we don't use macros all that much.
True.
It's weird to put it like this because macros are one of the biggest advantages of Clojure.
But use
but when you use them too much, you change the language to the point that it might become a different language.
Yes.
And when everybody is doing it, you no longer write in Clojure. In Scheme, it's popular, or in Racket, it's popular to do those reader macros and make your own language. In Clojure, it's not. There are a bunch of macros provided by the language itself. Then there are some things that you might like I like diamond arrows for threading macros that you can. It does not have to be first or last parameter, but you have this like diamond where you can put it anywhere. But I don't use a lot of macros, so I think that it like makes moving code from one project to other project much simpler because you are not porting between languages.
Yeah.
Because macros turn code into, or it turns Clojure into Clojure plus something.
It just occurred to me like I think this sort of dovetails on what we were talking about earlier about like Clojure having this smaller set of core data structures and functions. I think this is why different Clojure libraries work well with each other. It's because the big promise of OOP was like all this code reusability or whatever. And anyone who's ever written anything in C++ and tried to use more than two libraries together with each other at the same time has like, wanted to pull their hair out. They're just not very compatible with each other.
Yes. Yes.
It's hard to make them play nice with each other. I don't feel like I have that problem with Clojure. I can
Yeah.
mix and match
So
things very easily without it.
I am not expert on C++, but if I'm not mistaken, there used to be like two competing frameworks, like stdlib and Boost, right?
Yeah.
And when you worked in one, you didn't use the other. Right.
Most of my C++ programming in my earlier days was doing graphics programming related stuff, right?
Mm-hmm.
And in graphics programming, all the time, you have the need of things like 2 or 3 or 4 dimensional vectors of booleans or floats,
Yeah.
doubles, or matrices of various sizes and various
Yes.
booleans, and every single library implements their own version of those things, and they're all incompatible.
Yeah.
It's just maddening, like you
Yeah.
try to use some sort of like I don't know, like inverse kinematic solver with some other library that's supposed to be doing like some computational geometry thing, and they just like can't hack it with you at all, and you end up writing all this adapter stuff, and it's like inefficient, and it like ruins all the purpose that you're using something a low level language like C++ to do in the first place. And it's I think it really comes down to that interface problem. It's that every class is creating its own API, and that API is something that has to contend with it being compatible with every other API that's out there.
Yeah.
And this proliferation of APIs just is a nightmare for, like, you can't reasonably expect someone who writes one library to understand the compatibilities they might have with everything else that's out there. It's just it's too overwhelming, right? Whereas if everyone's writing back to essentially the same data structures, if we create new data structures very rarely, and probably for very specific implementation purposes, like, I don't know, if you write core async or something like that, you might write some classes or something to handle that, right?
So in Clojure, so for example, this graphics programming, most likely 80% of it will be like linear algebra stuff, right? And in Clojure, if you don't use GPU, you would be using basic data structures. If you do use, you would probably end up using Neanderthal. And that's it, like 2 options. And yes, in C++ it's quite possible. There is like 20 competing libraries that can do this. And at the same time, what helped Python is NumPy. This one library that captures all of those needs. And it helped the community also, like, to build everything around one library. In Clojure, if I was doing GPU stuff, I would probably use just Neanderthal, and I would not think of rebuilding my own stuff, re-implementing all of those things from scratch.
Well, I mean, this is a bit apples and oranges in a way. Like, I don't, although I have messed around a little bit, I wouldn't really recommend anyone using Clojure to do high performance numerical computing.
Yeah.
I think its wheelhouse is data transformation, I think.
Mm-hmm.
Like, you have some complicated shape data, you need to turn it into some other complicated shape data through some sort of aggregation or processing of some kind. Clojure is your language, right? Like, it's wonderful for that. C++, not so good for that.
Yeah.
Right? You want to pump out like 50 million polygons a second, then I don't think Clojure is your language. You can try to force your way into that world, but you're going to have to force your way to become the thing that you don't want to be in order to succeed at that, right? So
I wonder how Chegg will do.
I don't know
in this matter.
No. I'm not sure what the objective is exactly, right? I mean, we have Babashka, which is capable of fast startup times and doing things like that. Are they trying to write things like AAA games in Clojure? I don't think so. So
no.
I don't know what the objective is exactly, but
so I know a couple of people who are trying to make games in Clojure, and what they do is they use Coffee library that it's like a bridge between C and Clojure, and all the code that needs to be exempted from garbage collection is actually in C.
Yeah.
And you have this bridge that makes it easy to exchange data and messages between each other. So this is how they bypass it, because Clojure has garbage collection pauses. The language itself is super fast. The problem is garbage collector. Jank is directly, like on its website, is speaking about Clojure hosted on C++ and LLVM. So you might have your lunch and eat it too. You could potentially, I don't know, I haven't
I
tried
mean,
Jank yet.
it's still going to be garbage collected, right? It has to be. In order,
No,
how,
no,
how can it not?
I don't
How
want
can
to.
it not support closures? I mean, how do you write a closure in Clojure
So
without?
it's a Clojure dialect. Jay Wilkinson calls it a Jank programming language. It's not Clojure. It's yeah. I have opened the website. So Jank is strongly compatible with Clojure and considers itself a dialect of Clojure. So it is not. The goal is not to be able to compile any Clojure application to C++.
Yeah,
The goal is to give you a Clojure-like experience, including REPL,
I just
while
find it hard to believe that you're going to get away from garbage collection if you're able to write something like a let expression that returns a function that accesses the members of the let expression. Like that has to be garbage collected. Like if you don't, I can't imagine how that would work without it.
I don't know. I can only speculate. I don't know if you have to manage your memory or not.
Yeah.
And I have been speaking about Junk a couple of times. Actually, it's a shame that I did not study it yet.
I mean, I'm really just talking off the cuff too. I mean, my whole experience with Jank is like looking at their webpage 3 or 4 times, but like it's,
Yeah,
I haven't really tried to write any software in it or anything. And I see that they're like, they're getting there. Like there's a lot of things they're not compatible with and stuff too, but,
yeah,
um,
yeah.
it's interesting. I mean, I'm not trying to discourage them or anything. I'm just like, I'm not sure I understand what the objective is exactly. I mean, maybe it's portability. I don't know. You know,
Yeah.
LVM
So,
does run on everything. So
so I suppose not having garbage collector might be the objective, might be the advantage.
I think a
That
world
you,
without a garbage collector is.
it's great. I like it. Like every time
I
I
think
can use it, I use it. It's just like there are situations where you can't use it. And if you can't use it, you have to use something that lets you work without it. And Chink might be this,
well,
which is, of course, very different than classic web applications, workloads that can be processed asynchronously, and so on. We speak very much about real-time systems or devices that have very low power, very slow CPU, and you need to keep it all low level.
well, don't get me wrong. I love Clojure. Okay, but I think for me, it's always about choosing the right tool for the job.
Yeah,
And I think there are spaces where Clojure is not the right tool for the job, and there are better tools. I mean, exactly what we're talking about. I've on multiple attempts made a Clojure-based game which uses Vulkan as the backend, and essentially
yeah,
all the application sort of logic, the game behavior is in Clojure, and it ends up like essentially dumping a bunch of raw data into a Java NIO buffer, which it hands over to Vulkan to render, right?
yeah,
And so the rendering is very fast. Um, it's great to be able to write game logic in Clojure and have all the facilities and multi-threading and all kinds of stuff that you can do there. But as an experiment, I decided, well, let me try the same sort of approach. And by the way, it's very functional in its things, right? You can think of the whole game loop as like a reduce, right? You have like new keyboard and mouse events. Those are the elements of the collection coming in. Your current game state is the the first argument to reduce, you
Yeah.
introduce a new game state from that, and then render it. So it's like, it's all very elegant from a functional programming point of view to think that way, right? But then I decided, well, why don't I try to do the same approach to writing a game, but write it all in Zig? And
Mhm.
it turns out it's a hell of a lot easier to write in Zig, because
Yeah.
in Zig you have very direct access to the memory of what's happening. You can do a lot of the same sort of things. You can have like an A/B, like blue-green sort of buffers that you're alternating between, where you fill them up and throw
Yeah.
them away and fill them up and throw them away. You can still operate in a very functional sort of way, where data is only copied in one direction from one thing to the other and back and forth. But Zig can do like pipelined, vectorized linear algebra math on the CPU, like super fast. It can
Yeah.
iterate through a tremendous amount of data, like way faster than Clojure can. And it can be written in very straightforward, simple ways to do so. It looks kind of like C, but it's weird.
It could.
It's weird.
It looks like C. Yeah.
Weirdly like both higher and lower level than C, right?
Yeah.
It has like more control than C, but it has less footguns than C. And it's a totally different way of thinking, and I love it too, right? Like there's no reason why, like you're not like betraying Clojure by writing something in a systems language for solving a systems problem.
Yeah.
Right? And so like I think like at the same token, I would never try to write a web server or some sort of business logic thing into it either. Like to me, it's perfect for this very high performance
Yes.
thing, but I would never try to do the kinds of things I do in Clojure in it. It would just be nightmarish.
Yeah. I would not make a first-person shooter game in Clojure. I would be super happy to make a turn-based strategy in Clojure. So yes, Clojure has Clojure will be much more expressive, but its underlying platform, even the data structures in Clojure are based on an expectation that memory is cheap.
Yeah.
But if you have and adding to memory, changing memory like Atom, even if you store just a few bytes, but if you modify those bytes many times, it can, bloat, it can grow. While in this point, you should use transient memory structure. But in Zig or language like that, in C++, it would just change the memory as it is, risking a whole category of errors that might be caused by.
If you write something in a very low-level language, it's reasonable to start thinking about things like cache line invalidation.
Yeah.
Like really high performance things, like those things are just sort of off the table with Clojure. You can write Clojure in a style which is more performant than badly written Clojure in a style that isn't performant, right?
Yeah.
But the truth is, you're never really going to get anywhere close to the kind of performance that you would get in something like Zig. Because in Zig, you can think about things like, how many bytes am I moving out of main memory into the first level cache as I'm iterating through this data structure, and how many of those bytes am I accessing versus the ones I'm not accessing, and is that a good ratio in order to not invalidate the cache line? You are nowhere close to thinking about those kinds of things in Clojure, nor should you be. Right?
Yeah, so the thing is that very often, if you are not building like AAA game, or if you are not working for high performance fund, nobody will pay you to do this level of optimization. And I found that very often unoptimized Clojure is running, let's say, at 50% performance of unoptimized C. And of course, you can optimize C if they pay you to do this. And Clojure being hosted on JVM is actually over time getting faster. Like Alex Miller told me that some of the things that he had in his book, if I remember it correctly, he deleted those sections on Clojure optimization because JVM got so fast that they are not needed anymore. You just write idiomatic Clojure and JVM will optimize it just fine. And you don't have to care about those things. And actually, the only thing that, like, except obvious problems, obvious errors that can be in any language, like, the only thing that I think is specific for Clojure would be probably lazy sequences. They can be slow, but besides, and you should like pull exactly batches in the size you want to process instead of using lazy sequences that also use batches inside. So this is one thing I would try to think of to write high-performance Clojure, and the rest I would just write idiomatic Clojure and leave it to the compiler and leave it to JVM.
The truth is, if you're not making bigger mistakes from an architectural point of view, it's probably fast enough.
Yes.
Right. Like, just to give you a feel, like some of the stuff that I do professionally, usually the response time that's like in the Clojure evaluation part, let's say from the moment that a service kind of like receives a HTTP message, does all the business logic evaluation and is done, is like usually like 30 milliseconds or something like that, or 50 milliseconds.
Yeah.
That's plenty fast enough.
That's very fast, yes.
For that purpose, that's plenty fast enough, right?
Yeah.
So I think that where you get yourself into trouble when things start taking like, and I have seen things take like 30 seconds to do that.
Yeah.
It's when you start tying yourself in knots with things that are unnecessary, right?
Yeah.
You make some sort of very weird abstraction and then you massively overuse it in some way and get yourself into some trouble that like, you don't even know really what it's doing evaluation wise. Maybe it's doing tons of computation it doesn't need to do and then throwing it away and things like that.
Yeah. Yes.
You don't fully understand what's going on. So I think just being a little more concise and clear about like what it is you're trying to do, typically Clojure performance is plenty good. You know?
Yes. Yes. Most of the time when it takes much longer than it should, it will be bad solution that would be bad in any language. Like, for example, running 100 SQL queries that can be one. Or the opposite. Once I wrote very complex SQL query, and then I split it to two simpler ones, and actually it was 30 times faster. Or reading from disk many times per second instead of reading in one read, let's say, and so on, like things like that. But it's not specific to Clojure.
You know, I've made a front-end application that on initial load does about 1,000 queries.
Yeah. Yeah.
That's going to be slow. I mean, like, there's no way that's going to be good, you know? Like,
you know, CMS, Drupal, I think, for PHP, like it was something like that, in Drupal, if you turn off caching, just empty load of default homepage was hundreds of SQL queries. Like after installation, you did not change anything, you did not even create your website yet, and it was already doing, because it was a result of times where people wanted to make everything as modules that are completely independent. Mm-hmm. That means that like the same data are selected from the database multiple times, for example.
Yeah.
Because you did not want those modules to exchange data in any way. So yes, this happens. There are examples in the world that do exactly this.
I mean, it's I remember seeing, like in Reddit, I don't know, a couple months back, maybe 6 months back or something like that, someone posted a stack trace that was from, I know it was some sort of, because I saw some swing stuff in there, so I know it was some sort of Java web service of some kind. And it was like literally like 400 levels deep.
Yeah.
Now, there is no reason in the world that a piece of software needs to be levels deep in the stack. That is absurd. Like, that is just insanely more.
Yeah.
There's no reasonable justification.
Yes.
I don't even know what they were doing. Like, it's just not possible,
yeah.
Right. clearly,
It was probably something like a framework that was generating computation based on some XML files or something.
something
I would expect something like that in Java.
right.
Um, yeah,
I,
it's true. There is no
so far
reason to
away
have so
from,
deep.
I don't know. I think there's another tendency, which I've noticed, and I don't know if this comes from just my age or something like that. Like, when I first started writing software, there really wasn't a lot that you could build upon. Like, in a lot of ways, you were sort of like almost building from the ground floor, always,
Yeah.
right? There wasn't just like tons of libraries out there you could just grab and use to do something, right? So it's like, it was really like the language was like your your main tool,
Yeah.
and then from there is
Yes.
like kind of up to you, right? And so it
Yeah.
meant that every person that I interacted with was used to kind of building stuff from like an algorithmic data structure level from scratch,
Yeah.
literally writing the implementation of the data structures to do the thing that they're doing.
Yes. Yes. So besides like short experience with Quick Basic, I was actually starting with Turbo Pascal, and we got standard library from Borland, and that was it. That's what we used, and everything else had to be implemented by developers.
Now, I mean, you can say that maybe it's like
Yeah.
the battle of days in some ways, right? But the thing that it led to is that oftentimes you would say, okay, I have some objective I want to achieve with my
Yeah.
program. And you would think about what is my clearest, shortest path to achieve that thing? How do I take into like all the constraints of performance and memory usage and all those things to
Yeah.
get to the thing that I want to achieve? And I don't care if it's going to solve anyone else's problem. I need to solve my problem, my specific problem,
Yeah.
right? I feel like the state of affairs these days is your typical, junior developer. The first thing they do is they search around and they figure out what they can glue together.
Yeah.
Right? In fact, that might be where they end. Like
Yeah.
it might be conceived to them that it's not even possible to achieve it if there's not something out there that you could glue together with something else to achieve it, right?
Yeah.
And what you end up with is some Apache library that with 34 dependencies and some other thing
Yeah.
like this, and you put them together and you have this like monstrously complex thing to try to do something fairly simple. Like I think one time I tried to get a base 64 library out of Apache and ended up pulling like a dozen dependencies. I was like, what the hell? Like the implementation
Yeah.
of base 64 should be like half a page of code. Like it should be something like
So,
tiny, right?
yeah. Yeah. Another thing I noticed is that each new abstract layer has to implement everything. So now when you have web app frameworks, you end up with access to data being implemented on the framework layer, for example. However, and that's something that's criminally underused, is that in SQL databases, there are multiple users. Like most applications I see from other people have just one user that can do everything. I really like having multiple users in application. So BI has only user that can only read. API has only user that can do things that API is doing. Then there is like, 5 users easily that can do only things suitable for this user. And using roles that prevent changing data that don't belong to you. You can still do some checks on the up layer, but existing databases will be always much more tested than your own code. Those users existed in Postgres 20 years ago already. Many people use them. It's not likely that there will be any bugs. So, or any bugs you will run into. So this is one of the things I really like using that is like ignored by majority because they are thinking on higher level. They are thinking on the level of application language. But this actually adds a lot to the security of the application. And yes, you have to know all the layers below. Sometimes it might make sense even to create like system users and have multiple system users. This is more rare, but it might make sense in unique situations.
Phenomena of people only understanding the sort of top layers of the wedding cake. Like it's
Yeah,
one thing to say that I'm going to use this layer because I know all the way down and this is an appropriate thing. But like when you're using some higher level interface to something because you think you don't need to understand what's going on underneath, you might not be doing the right thing at all. Like,
yeah,
and I think this has led us to go astray in a lot of ways. Like I just my go-to way to solve problems is to think what the clearest way to solve the problem is and then see if there's anything along the way that can help.
yeah,
Not look and see what is out there and what I might be able to cobble together in order to solve it, right?
yeah,
Which leads to much simpler and much more direct solutions to problems, and also means that I have to think more clearly about what it is exactly I'm trying to do. I'm not succeeding just by managing to get one API to talk to another API. I'm like, if I don't know exactly what's going on there, that's not really that helpful. I mean,
yeah.
the best,
But sometimes it became impossible. Back in the day, you implemented code for a certain architecture. Now everything is in Docker. So actually, like you will not probably write application to be optimized to use
sure.
security mechanisms in FreeBSD if it's the system of choice. But actually, FreeBSD might be the best choice in certain situation, or OpenBSD will probably have many use cases that might make it absolutely ideal operating system.
Yeah, I mean, I
Uh,
think that's true, but like, have you ever like talked to a cloud provider like Google or AWS about what's actually going on inside? Because like when you think that you upload your containerized service onto some like instance in their thing, that's like the top level of a wedding cake of like 5 or 6 layers of virtualization below that. Like you are so far away from the actual hardware. It's
yeah,
like ridiculous. You know, it's like if you look at some of the stuff that GCP does with their networking, you're like, that's not even possible to do with physical networking. What the heck? What is
yeah,
that? What is this paradigm you're giving me? Because that doesn't look like how networking works. Like you know,
yeah,
um, so in some ways, I think that I personally have a kind of longing for being much closer to the bare metal. Like there's something in me that responds to the idea of like where there's like this Erlang thing I think where it was like a hypervisor app that like you send a packet
yeah,
to a network port and then it like spins up your function from the hypervisor, executes it and responds to the network thing and then shuts down again. Like there's no operating system even. It's just like
yeah,
it's like as low level as it possibly can get. Those things are simpler, right? Those things are easy to
yeah,
understand, right? Like I think we're getting to this point where we have so many layers in the wedding cake that we don't know what we're doing anymore.
yeah,
We're just like, oh wait, I guess it works, you know. But it's
yeah, yeah.
and
Like it makes work simpler. So I'm super happy that we have got to 1 hour 42 minutes without mentioning AI. But like now AI by default will put everything to Docker. Will use those like highest level frameworks. So actually this might become such a big default that's saying, oh, you can solve it directly on the operating system level, or like Erlang. So we like the platform is solving this for you. You just like create a supervisor actor that will restart. It will kill actors that misbehave and get to the invalid state. Uh,
I don't know.
you as a developer will have to explicitly know about it and explicitly ask for it, and then you will get it. A question is how to spread this information, how to tell developers that it exists and that it's there.
Well, I fear that we're heading in some sort of fork in the road, right? Um,
Yeah,
I think that first of all, I think my take on we can say the word AI, but what we really mean is LLMs, right? Uh,
yeah,
the real topic of AI is a much bigger and much more interesting topic, I think, than LLMs, to be honest. Uh, and I think filled with a lot of promise. I think a lot of what's been happening with LLMs, in my opinion, is not very good recently. And um, I think the problem is this. Um, my job involves a lot of things. Writing software writing actual code and making a commit is a
Yeah.
small part of it,
Yeah.
right? The bigger part of my job is understanding a business and understanding how to solve problems related to it using technology, right?
Yeah.
It's engineering. Engineering is not writing software. Those are not the same things, right? Problem solving is
Yes.
not the same thing as writing a function that
That's
implements
true.
a code, right? And I think that we've conflated these things and compacted the whole process to think that like all you get is like some guy at Y Combinator like vibe coding his solution by just saying, I think it would be nice if I had an app that did this. That's ridiculous. Like he's not thinking about the
Yeah.
problem very much, right? To say that, right? And the other thing is that LLMs don't think at all. There's no reasoning whatsoever. They're mimicking patterns of behavior, right?
Yeah.
Now, I think that they're wonderfully interesting things, right? And I think that they have utility for sure. They will never go away. Like their utility is here,
Yeah.
right?
Yes.
But I think that people have largely in the world has largely conflated what they're good at and what they aren't good at. And so for instance, I'm probably very atypical as a user of AI or LLMs. I do not use LLMs to write a single line of code
Hmm.
ever.
Yeah.
What I do use them for is seeing if I'm finding bugs in my code.
Yeah.
They're great at that. They're great at finding patterns
Yeah.
that human beings make common mistakes on. Like,
Yeah. So
right?
the question, like, when you speak about fork in the road, so one of my sons is interested in becoming a developer. Before LLMs, if he asked me, I want to be a developer, how should I do it? I would know what to tell him. Like, I started in 90s. I got Linux on floppy disks. I was staring those command line and I didn't know what to do. But so I was playing. All of that was just playing with technology. It wasn't money motivated. Uh, we knew that there will be money in software development, but it wasn't the motivation. Motivation was that you could build something new
Yes.
with some new technology, making something that was happening for the first time on Earth.
Yes.
Machines did things that were not done by machines before.
Yes.
And even when we have got better languages, more powerful computers and so on, the path into it was the same. You will just play with the whole operating system. You will play with the file system. You will try to debug applications. You will try to crack something. You will try to set up HTTPD and so on. This was the way. Now I can do everything, all of those things. So the quality of you, if you want to achieve things, is if you can ask the right prompts. So you can say, oh, now you overcomplicate things. You do this, and it will say, it's like, oh, you are right, and do the right thing. How do I teach my son to get to this level of depth without all of those hundreds or thousands of hours of tinkering with
You don't.
system scripts, boot sector, breaking the computer and reinstalling it multiple times?
I think what you're saying is very important in that the group of people that I feel the old guy saying this in my generation, we came to computers because we were fascinated by them. We wanted to know how they worked. We wanted to know
Yeah.
everything about how they worked, right? We wanted to be able to
Yeah.
make them do things, right? We gained
Yes.
satisfaction for being the person who has the knowledge of understanding how they work and being able to bend them to our will to do the things that we want
Yeah.
to do, right?
Yeah.
I think I was probably 22 or 23 before it first occurred to me that someone might pay me to write software. And I'd been writing software since I was like 10 or 11 years old.
Yeah.
Like I probably had more professional experience writing software than most of the people graduating from college did. You know,
Yes. Yes.
because I was so fascinated by it, right? Because I was interested in understanding what it
Yes.
is, right? Now, I think there's another, I don't know when it happened. Maybe it was because of the dot-com boom or something along those lines. There became a group of people who entered the software development era not because they loved it, but because they saw it as a good career choice.
Yeah.
And they see their job is producing artifacts, right? Someone says, I need you to
Yeah.
do this Jira ticket. They do the Jira ticket. Someone gives them money at the end of the week, right? They're not actually that
Yes.
interested in how it works or what it,
Yeah.
or they don't share that love of writing software. To them, it's like a sausage factory, right? Now,
Yes.
to a person who views the creating software in that way, um, maybe an LLM is the best thing ever. It allows them to crank out sausage faster. Maybe they don't care as much about whether it works as well, or but they didn't really care before either.
Yeah.
Let's be honest, you know, um, and they're going to become less and less skillful and less knowledgeable about what it is they do. Right?
Yes.
That's kind of what I mean by down
Yes.
the road. I think there's a group of people who are not interested in the artifact as much as they're interested in the process.
Yeah.
And understanding how these things work, and that's the fascination to them is building upon this. This is like it's the most unique profession I think has ever existed. The only thing I can think that's close to it is maybe like carpentry. Like carpenters
Yeah.
create jigs in order to make the thing that they're going to make. It's like making the tools
Yes.
to make the tools to make the thing. We do that more than anyone, right? Like we get so
Yeah.
far down that rabbit hole. We're making the thing to make 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 the thing.
Yes. Yes.
Now, if you introduce LLMs into this and say, you don't need this top 7 layers of making the thing to make the thing. Just here's the thing, and don't worry about how it's made.
Yeah.
Okay, well maybe if what you're interested is just the thing, that's a good thing. But the thing is, you can't really specify what that thing should be very exactly. So you're going to get some sort of like middling, generic, middle of the bell curve.
No, I mean, like, I can imagine him going through all of those thousands of hours of tinkering and trying things. It's fine. It's just Anthropic and OpenAI are explicitly making their models better at development and IT-related stuff. So yes, those people who want to produce artifacts will end up with massive tech debt, with code they don't understand, etc. But there are now probably billions of dollars being spent to trillions. Yeah, but like if we speak about like they spend money on everything to replace accountants and lawyers and so on. But at least billions are being spent to make developers obsolete as a profession. So not gonna happen.
I don't believe it's going to happen for a couple of reasons. Now, are there people whose jobs are more under threat than others? For sure. Like if my job was like to write the kind of boilerplate C# JavaScript, middle of the bell curve, do the thing that's been done 1,000 times before, but just needs the branding of my company on it. Yeah, okay, you should probably be worried. Because frankly, that stuff's not that hard to do, not that valuable, and they're not going to be willing to pay you for that low value stuff, right?
Yes.
The person this is a little bit like how McDonald's affects people who are a good chef and run their own restaurant, right?
Now,
clearly,
that's true.
If people go eat hamburger at McDonald's, they won't come to the restaurant because they get dinner somewhere else, right? So you can say that, okay, maybe this chef who runs his own restaurant and makes this really great food is somehow impacted by McDonald's. But I don't think really, because I think they had different audiences to start with, right? I don't think there's anyone who was thinking of going to this guy's restaurant who decided to go to McDonald's, right?
That's true. It was always true. Like back in the day, all websites were made from scratch and small e-shops. And then we have got Magento and whatever. Yeah. Then there was low code and no code. So if a company needed a couple of CRUDs and they...
How many no-code solutions have you ever seen work?
So actually, I have got quite far with Notion and Airtable. And in Notion, for example, we used it for our content management, for company like giving tasks, intra-company wiki, things like that.
Well,
We
I would
use
say I
Notion.
would say that those cases are the data is the content. I mean,
Yes,
right? There, it doesn't really do something, right? It really just
yeah,
is something.
it's just data. Yeah, there are no side
Right.
effects. Maybe side effect is just you get notification when somebody mentions you
Right.
or when somebody adds a comment.
So, like,
That's
yeah,
it.
if you want to vibe code a blog thing, yeah, sure, go ahead.
Yeah,
It'll probably be perfectly fine, right? Now, stylistically, maybe it might not look so great, but like, whatever, if just the
yeah.
functionality. On the other hand, if you want to write a piece of software that does something unique in the world, no amount of Anthropic is going to hurt you.
Yes, yes. I like. Yes, but they pay experts on all domains. They pay them hundreds of dollars per hour to basically train uh, neural network or LLMs to do expert work. For a very long time, I was saying that LLMs will never be more clever than IQ 115 on IQ tests because
They're not,
most people who write on
they're not
internet
clever at all, though.
ha-
And
uh,
an IQ test is not scoring your ability to think. An IQ test is largely
yeah,
scoring your collection of facts.
yes, but you can create new IQ tests that are not in the training data
Okay,
set.
I'll give you an example that will just prove my point here. All right. So bear with me a little bit. I
Yeah.
went to an interview one time. I'll go say it was Riot Games. Okay. It was a
Hmm.
grueling interview process, and it was like 8 hours long. And the last 10 minutes, they're like, "Hey, we got 10 minutes. Like, you want to try something else?" And I'm like, "Oh, God!" Like. So they gave me this problem, right? I won't give you the whole problem, but basically, they gave me a little thought problem, right? And this thought problem involves writing something that looks like a program, but it's not in a language that I've ever heard of or anyone's ever used to do anything. And it doesn't involve a problem that you could Google. If you would try to Google this problem, you would not find it. You would not find
Yeah.
any kind of wiki page or reference or gist somewhere or anything that says about this problem, right? Now, in terms of like logic, it's not that hard to solve, right? I did solve it in 10 minutes.
Yeah.
But just as an experiment, I give this program to Claude and to ChatGPT and to Gemini periodically once every couple months and see how they do. They're
Hmm.
terrible at it.
Okay.
They spin in circles. They cannot. They basically say like, here's the solution, and it's totally wrong. And you go, okay, here's the problem with your solution, and they say, oh yeah, you're right. Yeah, look, I'll fix it, and then they give you something even worse. They because here's the basis of the problem. You're right. You can think of there's like a bell curve of knowledge, right? In the
Yeah.
middle of the bell curve is like, I want to make a web page that shows a picture or something, like, and like way on the end is like this problem I'm talking about, right? It's like
Yeah.
way off in the thin corner over here, right? No one has ever done this, right? Like no one's thought about this thing at all. They have nothing to train on. And because what they're doing is not reasoning at all, no matter how they like to say that they're reasoning, they're not reasoning. They're not thinking in any way. They're pattern matching. They're regurgitating a pattern that's been seen before in the world. And so if what you do as your job is a pattern that's been seen a lot, you're actually not adding that much value to it, I hate to
Yeah.
tell you,
Yes.
right? You're just regurgitating. And just give an example. Before LLMs existed at all, we knew what these people were like. These are the people who went to Stack Overflow and cut and pasted stuff out of there into their code without knowing what it does.
Yeah.
This is the same person who uses a prompt now to deliver code and commit their PR, right? They have the same amount of value now as they did then. And
Yeah.
neither of those times is that person a threat to a person who was thinking
Yeah.
about what they were doing, who was farther out in the bell curve. So all I got to say is that, yes, Anthropic is right. They are going to kill the middle of the bell curve,
Yeah.
right? And I don't know if this sounds a little bit elitist or something, but most of the people I know and work with are not in the middle of the bell curve. We would never hire someone in
Yeah.
my company who's in the middle of the bell curve.
So
They're not
if we are not looking at the developers, if we look at normal office jobs, even the people who are at the top of their career, they have 20% of time they solve really unique problems. 80% of time they are doing repetitive work they have done hundreds and hundreds of times before, and AI can actually automate those things.
And software in general can automate those things, right? And
Yeah.
I think that is the purpose of us writing software, is to get rid of those things that we do that are repetitive and mindless. And I'm all for that.
Yes.
And I'm all for using LLMs to help with that, right?
Yeah. So that means that LLMs will push people to get on higher level of abstraction.
Yes.
And that will push us to more unique use cases, which is a good thing, of course. And all technologies have always been like this. There used to be human copiers who were manually rewriting things. Then we got Xerox, and we got Command-C, Command-V, or Control-C, Control-V. And it's actually awesome that there are no, like, it was usually ladies, there are no like hundreds of ladies who on a typewriter don't have to manually rewrite company memos or whatever. So yes, we will probably move on higher level of abstraction, and people will get used to it. At the same time, as long as AI companies will exist, they will be motivated to extend from this bell curve to more.
I think they're already near the edge of what they can do, though. They're already training.
Do you think?
They're already training on all the world's data. Unless,
yeah,
and I'm talking about generative AI, right?
Yeah.
The current transformer model, I think, has reached almost its limit. Like, we should not expect it to get much better. Like, maybe it will get like twice it better.
I'm not so sure. For example, I really thought that there will be a physical limit to its intellect, and now
there is no intellect at all, and I think that's the biggest problem. The biggest danger I see with LLMs is not that it's going to take all of our jobs. It's that people are going to start abdicating their ability to think.
Mm-hmm.
And I'll give it.
Yes, this is a real problem,
because an LLM will answer any question you ask it.
Yeah.
The quality of its answer is, first of all, here's a common pattern I see in not programmers, but just like business people, right? They're like, okay, I've got a bunch of random thoughts, right? I'm gonna write them all down. I'm gonna ask ChatGPT or Gemini or whatever to help me organize my thoughts into some memo or something. And then I can present this to someone else, right? And and then they might even ask to brainstorm, like, give me like 5 ideas to do this X, Y, Z, or something like that, right? And like, oh, but I'm choosing the best one. I'm choosing the one that I like the most, and like, it's working with me, and we're like collaborating, we're like working forward, right? And I had someone talking to me about this process they were doing, and I asked them, well, can you compare to yourself what you think the output of that process would be if you hadn't used the LLM, and you had taken your rough notes and you had taken the time to work that into a memo that you would write and provide to people, right? Now let's imagine that in both of these processes, we delete that memo. How are you changed as a person in those 2 processes? What did you walk away with in that first process where you're going back and forth with the LLM? Did you learn something? Did you?
Yeah, so the thing is, actually, to create a memo, you have to study various things around it.
The problem, right? To express it, how to communicate. I'm sure all of us have had this issue with software where you go to talk to someone like a rubber ducky kind of thing, and in the process of explaining it, you're like, oh, I don't quite understand it, and then you think of ways to explain it, and you think through the problem more deeply, right? What I fear is that people in this very facile sort of back and forth with the LLM think that they're making progress and that they're thinking, that they're deliberating, but they're just imitating the process of doing that. Yeah. It's like they're imitating the process of doing the hard work. And the reason why, the way you know that this is true is because it's not hard work.
Yeah.
Right? Like you're not thinking hard while you're doing it. It's actually, you're very much like on the couch when you're doing it. Right?
Yes.
And which means that your those muscles in your brain that you would have like been doing the heavy lifting to build when you had to struggle through putting it all together yourself and thinking through the problem and how to express it to others, you're now failing to do. And
That's true. Yeah. I also I have read that basically IQ, average IQ, is already going down, and somewhere around this year or last year was a peak genius, like genius people with IQ over 130, was the year when the population, the world population, the most geniuses, and now it will be going down. There will be fewer of them.
yeah,
Uh, so, and it's not attributed only to AI. It's like screens, um, shorter attention span, people instead of reading books, consuming short videos. So it started before AI, and AI can definitely uh, make people cognitively lazy.
yeah. I think what it goes back to saying
Uh,
about your son is that, like, yeah, if you want to get to that point, you're going to have to do the work,
yeah,
right? Now, if your
yes,
objective is not to get to the point of being a person who has a very in-depth, technical, organized mind about problem solving, then by
yeah.
all means, like, vibe code your way there, But like, there's no way that the person who's vibe coding their way to the generic thing is ever going to become good at this stuff.
So if you have time, if you are clever, you still have to like, you should get good at something. With AI, used the right way, if you use it as a mentor, if you use spaced repetition, if you do things in AI can actually help you to be great at something, but it shouldn't be a replacement for your brain.
Right. I,
And you still have, like, if you want to be at the edge of the bell curve, on the right side, of the bell curve, you need to be good at
yeah.
something. You will not get good by just like asking AI to do something, getting result, consuming it. It's no different from consuming whatever Facebook or Instagram, right?
Yeah,
But
it's
if you
like
use
scrolling through TikTok. Like
yes,
that's the same effect on your mind, basically. Like you're
yes,
doing.
yes, and I think that both Anthropic and OpenAI actually are training their models to be engaging.
You got it.
So, so I think that world after AI exists for developers will be different. But if he wants to end up on the edge of that curve, he will have to put in work. For me, when I was a boy, it
That's
was no
good.
work; it was
That's
fun.
good.
I
Yeah,
wanted,
that's
I
all right.
wanted to try or window managers that existed on Linux, so I tried all of them, uh, and it wasn't a task. Nobody told me to do this.
Absolutely.
The thing is, yeah, a question is how should he approach the beginning of his, like, not career but like life where he will be specializing, when actually the original path might not lead to any edge.
I don't know. I mean, this might seem like a
Yeah,
bit of a impractical.
I don't want to sound negative. It's like AI will enable new use cases, new things, and when you do things right, you will build a deep understanding, and at the same time, you will still keep all the leverage. I think that me knowing technologies means that I am writing better prompts for AI. Uh, and without all of those experiences, I uh, I'm not using the fact that I had to defragment my hard drive. It's useless information. It's a funny story that we had to do it on Windows in 90s, but like, but I am using my knowledge to do to ask many prompts that are actually based on my understanding of the matter.
I think
So
there's a couple classes of usage of LLMs which I think are universally a good thing, right, and are helpful. The first one for me is the August one, which is like search, right? If there's a
yeah,
subject you know very little about, and you want to understand sort of what the lay of the land is, what the space you're in is, it's sort of hard to search for it traditionally, right?
yes,
Like LLMs are really good at that. If you say, like, give me the X number of things that are related to this, or explain something this, What you'll find though is that you can go up to a point, and at a certain point, you will start getting into an area where you don't have enough knowledge yourself to be able to ask a good question.
Yes.
And that's usually when you should stop. And then you
Yeah.
should switch to like pulling on one of those threads you discovered while you were doing that exploration, right? And then going deeper,
Yeah.
right? Like you will not become an expert by going back and forth with an LM like that. And the reason why I can say that is that take any subject in which you are an expert. I could say this to anyone, and go talk to an LLM about it.
Yeah.
You will find just quickly how surface the knowledge of an LLM really is, right? And how misleading
Yes.
it is, right? Now, if you're not an expert, most of what it's telling you is helping you become better. So it's a good thing, right? It's sort of like it's dumping like all the conventional wisdom on you that's out there, right?
It will give you best
Right.
practices. And of course, sometimes um, if you like, if you don't understand field, you should not be contrarian. Like, for example, I say, okay, I am no expert on climate science. So if they say there is global warming, I will trust there is global warming. If I'm expert in programming language ABCD, and if I see that something is terrible, if AI will tell me, no, 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 you should do it like this, I will be happy to say, no, you are mistaken, I oppose, and let's do it my way, and it will show that it's my way. So this is probably what I expect if he wants to be a developer, that he will build this like critical insight to know when something is off, when AI is not doing its job correctly.
I think the trick is not to get sucked into thinking that you can go all the way.
Yeah.
And it's sort of, I think the hardest skill with LLMs is knowing when you should back off. And this sort of dovetails into, I think, which is for me like the second big issue, which is reviewing my PR or reviewing my code in general, right? And especially if you give like selected prompts, like I want you to look at this component and tell me how like the test coverage is related to these things or something like that, right?
Yeah.
It's good at finding the kinds of defects that human beings frequently create because they're human beings.
Yeah.
Right? The things we forget. Like we did 8 of the 10 things and we forgot to. You know. Oh, we would have done those 2 things if we remember them, but we got carried away and we like forgot to do them. You know. Like it catches a lot of those kinds of things. But what's interesting about that process is if you take it to a code base for the first time and you say, okay, audit it, tell me what the defects are, right? The first list of 10 things it gives you, great. Like you read down the list, you're like, okay, first one, oops, yeah, I forgot that. Yeah, I got to fix that. Second one totally makes sense. I get fix that, right? If you keep doing that, what you'll find is soon it'll be like, okay, one of those things in the 10 in the list is like, man, I had to think harder about that one. And when I dug into it, it wasn't quite right. Like it didn't have the full context, and it was telling me something that was wrong that wasn't actually wrong because this other thing like accounted for that, right? You tell it that, and it's like, oh yeah, you're right. Yeah, you know. You keep doing it, you'll eventually get to the point where like half of the things are that way.
Yeah.
Or then like 3/4 of the things are that way. Like you have to have the discipline to say, I'm stopping. I'm not going to keep going and try to fix everything it tells me because at some point, all that it will be telling you will be wrong.
Yeah.
Right. And so it's just like that. You have to keep that discipline of like, yes, it is valuable at first. But its utility goes down the farther deeper down the rabbit you go. And I think that's a sort of pattern I can see with almost all uses of LLMs is like the more naive, the more kind of first application it is, it gives great demo in that sense, right? Like its first approximation is great, but as its approximations get farther and farther off until they start like swinging wildly like random noise, you know, at some point. The problem is if you're like your son first getting into programming and you haven't done the heavy lifting, you won't know when you've crossed that line.
Yeah. So one thing is in software engineering, you are never fully done. It's infinitely deep field, and you can build this depth I don't pretend I know everything, but you have to build this step, and software engineering is truly engineering. We were speaking about that today. And I found now one quote from Alexander Solzhenitsyn, which is great and super relevant. I think about that quote from time to time. It goes, I had grown up among engineers, and I could remember the engineers of the 20s, like 1920s, very well indeed. Their open, shining intellects, their free and gentle humor, their agility and breadth of thought, the ease with which they shifted from one engineering field to another, and for that matter from technology to social concerns and art. And in software development, it's the same. He did not know anything about computers, I suppose, and he was speaking about civil engineers, but it applies the same for software developers or software engineers. You need to be this like well-rounded person. But when you have problem, I give you solution, you know about the problem and solution. When you have a problem and you have to study the whole etc folder in Linux and go through 20 files and 19 are irrelevant, it goes, okay, so this is where I will be configuring this, and this is how I will be configuring that, and this is how I restart a service and install a package and so on. And this is why it's a problem that my system comes with pre-installed Python, for example, of certain version. This tinkering, and it's possible only because time of kids have very small financial value, so they can afford to waste this time. And one thing I feel sorry from time to time, I don't feel sorry that I have kids and responsibilities, but I have kids and responsibilities, and I don't have that much time to do this insane amount of tinkering, playing with technologies I used to have. Maybe that's something he needs to do, like just have fun with computers if he wants to work with computers.
Well, I would say this in a more general sense, just outside of the computers. If you want to give advice to a young person or someone who's like, I would say find the thing that makes you the most happy being engaged with. The thing that you derive joy from exploring and learning about, and whatever that is.
Yes.
That joy and that interest that you have in that will cause you to put in the hours to learn how to be good at it. And that learning how to be good at it will make you valuable to someone. And at some point, you will be able to support yourself in some way because of that. Does that mean you're going to be a rock star or the next billionaire? Who knows? But you'll be happy with what you're doing, right? And you inevitably, if you are good at something, the world will find a way to reward you for that value.
Yes, 100%.
So you shouldn't worry so much about what the career is going to be. You should worry more whether like you're engaged with the thing. And I think the career will come along. The world will find a way.
Yes, 100%. I must say this was time well spent. I would like to thank you. I would like to ask, how can people support you or follow you or learn more about your project you are working on?
Unfortunately, we were talking earlier, I have almost no social media presence. I'm a total dinosaur. So I don't have a bunch of handles to give you. I would say in general, keep a lookout in the Clojure community.
In Clojure and Slack?
Yeah. Clojurians is fine. You can DM me there. My name is just my name, Jim Callahan. I expect that like when I kind of get what I'm working on currently to a bigger state of completion and unveil it to the world, I will make it known probably through comms or through other things like that. And so stay tuned.
Fantastic. Thank you very much.
Thank you.